So owners are looking for what is a option in order to help my pet after I've been diagnosed with cancer. And we feel that immunotherapy can truly be that bridging gap there. When it comes to veterinary oncologists, there are about 300 that are actively practicing in the United States. So there's too many pets to be treated by too few veterinary oncologists. And again, if the owner's not going to move forward with chemo, we have a complete blue ocean of owners who are saying, now what? What other options do I have? And that's really where Torigen helps be able to bridge that gap.
Welcome to the People of Pathology podcast. I'm Dennis Strank. On this podcast, we explore pathology, laboratory medicine, and forensic science. Advancements in digital pathology have applications beyond human medicine. Today, we'll look at how it is revolutionizing cancer treatment for pets through personalized immunotherapy. My guest today is Ashley Kalinauskas, CEO and co-founder of Torigen Pharmaceuticals. We'll explore the challenges in veterinary oncology, how digital pathology enhances diagnostics, and the broader implications for both animal and human medicine. All right, here we go with Ashley Kalinauskas. I'm told I'm supposed to ask you about your dog, Dave.
Oh, well, one, he's in the photo behind me, but two, he's also sitting on my desk right now.
Oh, hello, Dave.
What? Oh, he's a mini golden doodle and
Okay,
is the light of my life.
okay. I understand there's a story behind his name.
His name is because my husband wanted a dog named Dave.
But why Dave?
Why not? Like he just wanted a human name. So we say our next dog is going to be Tony. So Dave and Tony.
All right, I like it. That's good. That's a good combination. Okay, well, all right, let's get into Torigen then. So you're the CEO and co-founder of Torigen Pharmaceuticals. Tell me about the start of this company. What was the inspiration for this?
Yeah, so I started Torigen from my grad student research. So I was a student at the University of Notre Dame, and my graduate work was focused on the development of personalized cancer vaccines. But I was also in a really cool program that combined science with also taking business classes. And really, the premise was, can you take what you're working on in the lab and potentially commercialize it into a company? So the professor that I was working with, Dr. Mark Sugo, he had developed a method for creating personalized cancer vaccines that preserved the outside architecture of the tumor cell in order to keep those antigens intact in order to present them back to the immune system as a series of vaccines. So he had done a lot of work for prostate cancer, ovarian cancer, melanoma, all focused on humans. However, we decided to move this technology over to veterinary medicine because 50% of all dogs over the age of 10 die from cancer. There's about 4 million to 6 million diagnoses in dogs each year. A lot of the tumors that develop in dogs are similar to those that develop in humans. So we decided that being able to bring this technology over to help our pets would be an amazing next step, but also really fulfilling. So decided to take pen to paper and write down the first iterations of our business plan in order to really showcase that we could take this tech and bring something amazing to the veterinary community.
Okay, I like this. This is a really good idea. So what year was this that this started?
So this was 2013 when I was in grad school. And
Okay.
then between 2013 to about 2017, it was more an idea than
Uh-huh.
anything working on it. And then come 2017 to 2019 was when we really started setting up our own lab, getting everything in place, running our safety studies, our preliminary efficacy studies, and saying that this could be a business.
Was there like a point in time where, or an event where you were like, okay, this is going to work. Let's move forward with this?
I think it was really the first time we raised capital. We took on $250,000 from investors. My professor was the first check into the business because he truly believed in this. And we knew at that time that this was a safe product to be provided. And we had some really good hints at, preliminary efficacy that made us say we're heading into the right direction. So In 2017, that's when I quit the job that I was working at in order to launch Torigen full time. So we set up a laboratory at the University of Connecticut because for me, Connecticut's home. So it made sense when you're an entrepreneur to be able to get things started there and then have really grown it ever since.
Now, I think you kind of touched on this already, but what sort of like gap did you see in veterinary oncology that you were addressing with Torigen?
Yeah, it really comes down to after a pet is diagnosed. And again, there's so many diagnoses of cancer in our pets, unfortunately. Owners don't want to put their pet through chemotherapy. Like that is their biggest barrier. 90% say, I would never put my pet through chemotherapy. So if that's the case, and you have so many pets that are diagnosed, essentially what you have is you do nothing. So about 40% of owners decide to do nothing. About 50% of owners would decide to surgically excise that tumor. And then about 10% decide to move forward with chemotherapy or radiation therapy. But if we take that population that just say, I'm just doing surgery, well, depending on what we're dealing with, there's a chance that surgery could cure it. But more often than not, it's going to come back. So owners are looking for what is a option in order to help my pet after I've been diagnosed with cancer. And we feel that immunotherapy can truly be that bridging gap there. When it comes to veterinary oncologists, there are about 300 that are actively practicing in the United States. So there's too many pets to be treated by too few veterinary oncologists. And again, if the owner's not going to move forward with chemo, we have a complete blue ocean of owners who are saying, now what? What other options do I have? And that's really where Torigen helps be able to bridge that gap.
Okay, I like this a lot. I mean, I've had pets for as long as I can remember, and some of them have had cancer. So I can definitely relate to what you're saying about having to make that sort of decision.
Yeah.
I want to get into a little bit more detail about how this immunotherapy process works.
Yeah.
Can you talk about that a little bit?
Yeah, absolutely. So our technology is how we're taking that tumor cell and again, preserving that outside architecture and those antigens on the surface of that tumor cell as the backbone for the creation of a vaccine. So when I think about cancer, I really think about the tumor cell as the fingerprint of what went wrong. You have a DNA that's resulted in a mutation, and now that DNA is being transcribed and translated into different proteins on the surface of that cell. So that tumor cell now looks different than a normal, healthy self cell. Now, cancer's tricky, right? Cancer finds a way to hide not only from the immune system, but it has either a nice way of walling itself off. It's starting to get its own blood flow. It's starting to block the immune system from recognizing that those tumor cells are really there. But by surgically excising that tumor, the goal is to remove the majority of that mass. But we know that there's sometimes, if you don't get good margins, there's cells that are going to be left behind. So our process is the tumor gets surgically excised, it gets sent into our laboratory. Once that tumor is received at our laboratory, we're going to take a portion of those tumor cells, so take a representative portion, take them out, put them in the -80 freezer, take the rest, put it into formalin, and get the diagnosis that that veterinarian and that pet owner needs. We need to understand exactly what we're dealing with. And if it does come back that it's malignant tumor, that maybe we didn't get good margins, and this is a tumor that has a high likelihood of local or distal recurrence, then we can move forward with the creation of the vaccine. So we take those cells, we bring them into a clean room, and then what we do is we bring everything down to a single cell suspension. We take those tumor antigens, we preserve them in a way that kills those cells so that nothing can further replicate, but we're taking that fingerprint, we're preserving that fingerprint, and then we're combining it with a novel adjuvant that really helps stimulate CD8 positive cytotoxic T cells so that when the vaccine is given back, so it's a conjugate of this adjuvant plus the tumor cell lysate proteins, it's being able to be provided back to the patient in order to stimulate a systemic response. So The goal is, can we prevent that tumor from coming back locally? But then, of course, if it is a cancer that has a high rate of metastasis, can we delay that onset of metastasis or prevent it altogether?
So how long then is the treatment process for the pet, or does it depend?
So we provide, or the veterinarian provides the vaccines back once per week for 3 weeks. So it's a prime boost
Oh, wow.
sequence. And then if we have additional cells left for that patient, we can continue to provide additional boosters a couple of months out.
Okay, I see. You mentioned when you were talking about this, if the tumor has a high likelihood of recurrence, does that matter? Like if it's a low likelihood of recurrence, do you not do this process? Is it only for high? Do you know what I mean?
Yeah, I think it depends on the overall comfort of one, the owner and the veterinarian, and it
Mm,
comes down to what are we dealing with, you know? There are some tumors like a mast cell tumor those are very common in dogs. They're common in a lot of pit bulls or boxers get these mast cell tumors. They're a
mhm.
cutaneous tumor and they're either classified as low grade or high grade. Well, a low grade, regardless of what you're dealing with, you have a 50% chance when it's surgically removed that it will never come back. So the veterinarian and the owner then have to decide, okay, well, if we have a 50% chance that the dog is cured just by surgically excising it, do we need to move forward with additional therapies? And, you know, more often than not, you don't have to. However, if it is a breed that's predisposed, if they've had multiple comeback of these mast cell tumors previously, then maybe the owners are considering that they want to do a little bit more in order to give another chance at it not coming back.
Okay, I see. That makes sense. So in addition to mast cell tumors, what other types of cancer does your therapy target
Yeah.
currently?
So we have data and peer-reviewed publications for metastatic hemangiosarcoma, which is one of the most aggressive cancers that we see in veterinary medicine. Also for high-grade mast cell tumors, we have additional data there. And then veterinarians typically use us to treat solid tumors like melanoma, squamous cell carcinoma, soft tissue sarcomas, or even agasaca, which is anal gland adenocarcinomas.
Okay, and these are the current cancers that you're able to treat?
Yep, those are the majority of the cancers that we treat. So any solid-based tumor, as long as it can be surgically excised, can be an option for this technology. It's just
Mhm.
up to whether or not it should be. So similar to humans with pancreatic cancer, right? Like, you're dealing with a very uphill battle on a tumor like that. And it's better to throw more things at it than just one avenue. So what we really say is, of course, like adding in multimodalities in order to treat cancer is always going to be the best approach. But if the owner's not willing to do that or doesn't want to put their pet through chemo, then it's like, okay, we have immunotherapy as a potential standalone option, or it can be combined with other therapies too.
Okay, that makes sense. Now, one of the really interesting aspects of this, for me anyways, is you're utilizing digital pathology to do some of this work. And I know you're working with Proscia's Concentriq platform. Tell me about this. How does digital pathology fit into this?
Yeah, pathology fits into the front end of everything that we're doing. Like being able to get that tumor sample in, we need to understand exactly what we're dealing with. Are we dealing with a benign cancer? Great. You don't need to worry about us. But if it's a malignant cancer, okay, well, now we need to figure out exactly how aggressive is this tumor? Where do we fit in for immunotherapy? Should we fit in? Or do we really say, "Hey, we gotta throw the kitchen sink at this because this is an extremely aggressive cancer that we're dealing with." So the pathology piece really helps us understand exactly what are we dealing with. The digital pathology piece helps us move faster. So I don't have pathologists on site here at my lab. They can be working from home, means that I can
Okay.
get some of the best pathologists, but it also allows us to take all of those slides, have a digital record of everything. And if we want to go back and further examine cases, coalesce them together, it just gives us more optionality as we continue to move forward. So, pathology is really the basis of whether or not we move forward with the vaccine as a potential option. And digital pathology ensures that I'm having a fast turnaround time. I have all of those images, and that in the future, there's some really amazing things that we could be able to move forward with.
Okay, that makes a lot of sense. Like, I have to imagine that there really aren't a lot of veterinary pathologists out there. So you've got, depending on what type of tumor it is, you can potentially utilize the best in the field, right?
Exactly. And it also allows us, so I have one full-time veterinary pathologist on staff. I have one part-time, but a pathologist, I mean, I feel sometimes you need to have someone to bounce things off of, and you want someone to bounce off that is an expert on that specific histiocytic sarcoma of Bernese mountain dogs. Okay, well, utilizing Concentriq, we know who exactly to reach out to, and we can have two pathologists review a case simultaneously in order to come to a decision together.
I like that. Because this is a new treatment modality, I imagine there had to be some challenges in bringing this to veterinary oncology. So, what were some of the biggest challenges of bringing precision medicine to veterinary medicine?
So I think overall, precision medicine on the human side always has the dollar signs in front of it, right? Like you're like,
Yeah.
it's going to be a $500,000 in order to create. Well, when we're creating these for pets, we knew that this had to be affordable. Period. Like you can't charge more than a couple $1,000s for a therapy. It's just not attainable for most owners. So that was our biggest piece, was how do we standardize the manufacturing of this personalized therapy so that the cells from one patient, of course, are only provided back to that same patient, number one. But number two, how do you standardize it in a way that you're able to keep your overhead and all of your costs down? So I think one of the big differences between like what a vaccine type approach that we do on our side versus what's being more traditionally done on the human side is a full genomic analysis of exactly what are those tumor antigens. We can't afford to do that on veterinary medicine, and we don't have the genomic repertoire in order for us to go back in order to say, this is the exact protein that is being overexpressed, and then we make a peptide-based vaccine and provide that back. So on the human side, they do a lot more full genomic-based analysis on really understanding what is the antigen that is going to have the best ability to bind to a strong T cell receptor, and then build out peptide-based personalized vaccines. On the veterinary side, we don't have the ability to do that. And we don't have the cash, of course, in order to build that. So our technology about just saying, hey, we're just going to preserve the antigens that are already there on that surface of the tumor cell, take that fingerprint, provide that fingerprint back in just a different configuration to help stimulate the immune response. We don't necessarily know exactly what is that fingerprint and how many of these specific proteins are being provided back, but at least we say, let's take that tumor cell, take it out of the body, turn it on its head, and provide that as an antigen to be stimulated with the immune system, that at least we're getting like down the football field in order to build a strong response by the immune system.
Okay, that's interesting. I mean, having been a pet owner that's gone through this and had to make this decision, I like that you're addressing the cost, up front. Like, we have to keep the cost down because I mean, let's be honest, if you're a pet owner and you have to decide what to do with your pet who has cancer, cost is a big factor.
Mm.
So I'm glad you're addressing that. The other thing with this, I wonder, is it difficult to collect data for just to study these things? Because I have to imagine there's, again, not a lot of, pets, patients out there that you can collect data from for this.
It's very hard, very challenging, and I think initially when I started the company, I was like, "Oh my gosh, look at the repertoire and the depth of the data and the information that we would be able to accumulate," right? There's no HIPAA. Like, I can get, records, and we can examine them, and we can go through everything. And, pretty quickly, and then it's really become more and more apparent the challenges associated with that because it's up to the owner to decide what type of diagnostics should be done and will they be willing to do in order to get that correct staging information, right? So if you as the owner say, okay, I removed the tumor, I know that it's a low grade tumor that has a low likelihood of recurrence. Fantastic. You can decide if you want to move forward with immunotherapy or not based off of your preference. Well, if you
Mhm.
didn't do the underlying diagnostics to understand, well, did we do ultrasound? Did we do x ray? Do we understand if there's already metastases that we may not be seeing on the surface? Then we're missing a big piece of what that accurate staging information is. So, on the human side, you are going to go through and you're going to go and ensure that you know the exact stage of what you're dealing with. On the veterinary side, it's up to the owner to choose whether or not to do those diagnostic tests. And because of that, now you have a patient who is starting with a low grade tumor, no metastasis, potentially a low grade tumor, but has already metastasized. They're starting at two different points, but you don't know where those patients are going to be starting. So a lot of general practitioners may not know for certain tumor types what the best diagnostic should be in order to ensure accurate staging. So that's a challenge. And then when we work with veterinary oncologists who utilize our immunotherapy too, fantastic. But those are actually some of the most challenging patients because that's the owner that's deciding to throw the kitchen sink at everything, right? So we're doing different types of chemo, different types of immunotherapy, maybe radiation therapy added in, and there's no standardization between those protocols. So, because of that, you have a lot of I always describe it to the apples and the kiwis, right? I need a patient population that are only apples in order to get accurate data. And if I'm comparing apples or kiwis and I don't know the type of fruit we're looking at, because I don't know the accurate stage, it becomes very challenging. So there is challenges. Like I wish I could say, I know of the 4,000 patients that I treated last year, you know, 88% are still alive, right? Like that could be like an easy thing to do. Well, what if I only treated only low grade patients that had a low chance of recurrence and the tumor didn't metastasize? There are so many variables that are unaccounted for that make this very hard to really get a pinpoint. So, prospective data in a controlled manner is really the only way that we can put our finger on the pulse of being able to ensure that what we're doing moves the needle forward.
This is the People of Pathology podcast with our guest, Ashley Kalinauskas from Torigen. We'll be right back. If you think it would be nice to have a helpful reference about digital pathology, I have some great news for you. Dr. Alexander Zhurov has written a book called Digital Pathology 101. All you need to know to start and continue your digital pathology journey. This book will help you whether you're a complete novice or a digital pathology trailblazer. You can get a copy of it by following the link in the show notes. LabVine is an interactive online learning platform where laboratory professionals learn, develop, and discover by sharing knowledge and building on each other's experience. The platform provides global access to internationally accredited laboratory-specific courses and other resources developed by lab specialists like us for the laboratory industry. LabVine is free to sign up, and you can use the link in the show notes to get started. Now for the rest of my conversation with Ashley Kalinauskas on the People of Pathology podcast. You mentioned a little bit earlier a couple of published research studies, and I want to get into one of them. So this study, the effect of immunotherapy on canine hemangiosarcoma. Can you give me a little bit of an overview of this study?
Yeah. So again, hemangiosarcoma is one of the most aggressive tumor types that we see in veterinary medicine. And what we wanted to do was be able to showcase, like, remove all the variables. Unfortunately, with this tumor, we know that these patients are going to most likely pass away from this cancer. And what we wanted to see was if we did surgery plus our immunotherapy, how long were we able to increase that overall delta between surgery alone versus surgery plus our vaccine? What we were able to see was a 3.5 times increase in overall survival compared to surgery alone. And it was able to actually be equivalent to maximum tolerated dose chemotherapy. So, surgery plus vaccine was equivalent to surgery plus maximum tolerated dose chemo in one of the most aggressive tumors that we see in vet med. That for us was okay, we put a stake in the ground in order to say that we're moving the needle on increasing the patient's overall survival.
Okay, I like this a lot. These seem like promising results. So, taking the results of this study, where do you go from there?
Yeah, so, combining that with our safety data has been the most impactful. So, we know that this is a therapy that could be provided very, very safely with minimal adverse events. We're talking injection site redness, irritation, and mild lethargy. Just like you got the COVID and flu shot on the same day that, you kind of feel a little crappy. Yeah, your dog's not going to feel super great, but in the grand schemes of a cancer therapy, that's pretty phenomenal overall. So, being able to combine an efficacy piece like that alongside our safety data, alongside additional efficacy outputs that we've published, that's really allowing us to take a stance in order to look at that data in its totality. We have another study that's ongoing right now. Wish it was running a little faster, but it's right now for horses with squamous cell carcinoma. Squames tend to be in horses pretty locally aggressive, and they can be huge tumors. We're talking like softball plus size tumors on these horses. And we're looking at just removing a couple of punch biopsies of the tissue in order to examine the overall regression of what's remaining. And this one's gonna be a really cool data output for us. I'm excited and hopeful to get that study done, but the first, 50% of the patients that are in and recruited, we're seeing not only a really strong clinical benefit, but a really good objective response rate too for utilizing this vaccine. Again, on a kind of in a way that this vaccine is not intended to be utilized, right? Like, I don't wanna have a softball-sized tumor and us only take a couple of punch biopsies. The better option is for us to take the majority of that mass away, and now if we have dirty margins, use the immune system to help clean up the dirty margins. That is going to be the best option for an immunotherapy like us to be utilized because we're using the immune system to finally help the cleanup and to really help aid that cleanup. But with these super large tumors, removing a couple of punch biopsies and then looking at that tumor regressing over time, that's really phenomenal to have a strong objective response rate. So excited to get that done and get that published work out too soon.
Okay, that's very interesting. You mentioned earlier talking about adverse events for the pet going through treatment, and I imagine a pet going through chemo, radiation therapy. It takes a lot out of them, just like a human. Is there a difference, or what is the difference between adverse events, or I guess recovery for a pet going through immunotherapy?
Yeah. So, I mean, a pet going through immunotherapy, again, injection site redness, irritation, mild lethargy, phenomenal. When we're talking about pets going through chemo, there's definitely a lot of hesitation of owners to just be like, nope, I don't want to put my pet through chemo, period. A pet's not going to lose all of their hair going through chemotherapy, right? That's not going to happen. But are they going to feel sick? Like, yeah, chemo cures cancer in 100% of patients, but because it can kill that patient, right? It's stopping
Right.
cells from dividing, it's stopping that replication, and we need cells to continually divide in order to live. So, I think that's the difference of you're trying to manage that overall toxicity level in order to have the best overall effect, but that toxicity level comes with those adverse events. So, of course, anywhere where we have cells rapidly dividing are where we're going to have those adverse events. So a lot of GI, a lot of course, lethargy and feeling sick. So I think looking at immunotherapy is a option that could be done within your general practitioner vet, minimal side effects. Do we know that it's going to cure that patient? What I can say is the absolute truth that we don't know that if this is going to cure this patient. We don't know the ability for a patient's immune response to be active. It could be higher in one patient more so than another. We don't know that. But over time, being able to help more and more patients and increase their overall survival, it's one of the reasons why veterinarians keep coming back to Torigen. We're a trusted expert in this space, but we're also going to give it real back to that veterinarian to provide to that pet owner of like, hey, here's where we are, here's what we know, and here's what we don't know.
What is like the general response from veterinarians when you introduce this treatment to them? Are they receptive to it?
They're like, hold the phone, like, this is exciting. This is
Okay.
I need an option. I need to be able to do something to help my patients. It's being able to finally have a solution for a problem that they're seeing on a very frequent basis. And that's one of the reasons why we decided to fold our own pathology unit into Torigen. One, because it just goes so hand in hand with what we're doing. Number one, we need pathology to figure out if this vaccine should be an option. But I really wanted veterinarians to not have to consider, where do I send this tumor sample to? Do I send it in formalin to the lab that I've always used? Like in veterinary medicine, we have IDEX and Antec as our big 800-pound gorillas in the room. They get all diagnostic tests and pathology being one of them. Or do I send it to Torigen in order to just preserve that option and keep that option for that pet owner open? So we want all tumors to come to Torigen from veterinary clinics across the country, because by keeping that tumor sample with us, you get the diagnosis that you need and you preserve that option for that pet owner in case immunotherapy should be an option to present on the table.
Okay, I got it. That's interesting. All right, so getting back to Torigen then, can you talk about any other upcoming projects?
Yeah, so the equine squamous cell carcinoma study going on right
Mhm.
now. We've also done a lot of exotic animals over the past couple of months. So right now, my exciting like I love dolphins, so we've been working on some dolphins with squamous cell carcinoma as well. I'm really
Oh,
excited to be able to see where that goes. We helped a lemur. We even helped a shark with cancer. This
wow.
deer, I would not want to be the one doing that surgery, that's for sure. But overall, like the business unit of the pathology plus oncology, I'm hopeful that we'll be able to really see that keep expanding.
Okay, I see. I see. I imagine more research studies to be published as you go along, right?
Keep
Right.
continuing that prospective work as needed.
Okay. Okay. I like it. All right. Then the last question I have for you. So, with digital pathology now being applied to veterinary oncology, how do you think this field is going to evolve? With using immunotherapy, digital pathology, how will those things help this field evolve?
Yeah, I mean, I think that by having the digital path piece, right? If I can coalesce all of my certain tumors together, right? Like let's take the dolphins with squamous cell carcinoma. Let's take all of
Okay.
those slides for those patients. Like not only do I have the digital footprint that I can go back and reference at any time, but
Uh-huh.
what if I wanted to look at the overall expression of a certain immunogenic protein on the surface of those tumors? Instead of going through and doing a full genomic analysis, can we do something like an IHC in order to see if we have an antibody that can be stained, and can we evaluate those slides? And then can we then take a blood sample from that patient and see, okay, of that protein, like what was there before and now what is there after in terms of building that delta of an immune response overall. So I think that there's a lot of potential that digital pathology brings to the table in terms of not only a preliminary analysis, but how we can kind of expand additional parts of our research, and how can you leverage AI in order to look at Okay, well, let's see the overall angiogenesis within that tumor. If we have a lot of blood vessels, does that mean that it's going to have a higher potential for that cancer to metastasize? And if it does metastasize, then is maybe the vaccine not the best approach? Maybe more combinatorial approaches should be given to that patient. So I think like having that slide and having that picture can allow us to always go back and say, if we have a research question, do we think we can start answering it? And how would we continue to go down that path?
I have to ask you about the AI piece then. I mean, are you utilizing AI now, or is that coming in the
So
future?
yeah, right now we are not utilizing AI. I think overall we're still, I think as a world, we're trying to figure out like how it can be incorporated best
Yeah.
because I think a lot of companies can say they're using and leveraging AI, but I think that unless you have an actionable insight from that utilization, I don't know, is it worth it? Like, I wanna
Mm.
make sure that if we're going down a path and we're using it and we're leveraging it, that we have an actionable piece that can be added to our business that can make this more beneficial.
Okay, that makes sense. Do you think there's aspects of what you're doing in veterinary medicine that can be applied or eventually could be applied to human medicine, to human pathology?
Yeah, so let's take what's being done on the human side in terms of personalized cancer vaccines, where,
Okay.
they take the tumor, they genomically analyze the difference between normal tissue and cancerous tissue, and then they look at what proteins are overexpressed, and then they understand what are the best T cell receptors, and then they make peptide based vaccines for those T cell receptors. It's that's a lot to explain because, there's a lot of different steps associated with that. I love the simplicity of our approach of just saying, let's just take that fingerprint because as long as we have that fingerprint, we have the proteins in the right configuration, the right binding conformation. We know exactly what peptides are, where they're supposed to be, and let's let the body decide really what to build a response to. And I think there can be power with combining the tumor cell antigen backbone of like our technology alongside those peptide-based vaccines so that we're just providing not only really strong antigen back to the immune system, but if we're missing, a really key critical factor in
Mhm.
our prediction methodologies, like at least the body, like it was there, right? And if it was there, let's keep it as, simple as possible to provide it back to the immune system. So I just think there's a lot of beauty in an approach like ours of just keep it simple.
Yes. Yes. I love it. That's a great message. I think that's a good place to end. Ashley, this has been super fascinating. I appreciate the opportunity to talk with you.
Yep.
So, Ashley Kalinauskas, thank you very much.
Thank you. Appreciate it.
If you're looking for another episode of the People of Pathology podcast to check out after this one, here's a clip from my interview with Dr. Nicola Perry as we talk about how she tries to inspire future students in veterinary medicine. Do you have any stories of ways that you've inspired future veterinary pathologists?
I have a relatively recent story that might kind of illustrate this.
Okay.
I came across a new student friend just a couple of months ago in August. Amy, she's a vet student at Liverpool University in the UK. So that's the vet school that I graduated from. And it's in my home city as well. And she had come across me on there's a really popular networking site for vets. It's called Vets Stay, Go or Diversify. Now it's a UK-based creation, and it's a brilliant creation, but it's a global entity. It's literally used by vets and vet students, thousands of them all across the world. So Amy, my new friend, she had found me there, and she had emailed me just randomly to tell me about her interest in pathology, and she asked if we could chat at some point. So we did. We had a Zoom call a couple of days later, and we chatted for a couple of hours. Actually, it was really nice, and I was just able to answer a lot of her questions that she had about working in pathology, how to kind of carve out a pathway to start in that career and stuff like that.
You can hear more from Dr. Nicola Perry all the way back in episode 37. All right, big thanks to Ashley Kalinauskas. So in this episode, we discussed how Torigen Pharmaceuticals is transforming cancer treatment for pets through personalized immunotherapy and digital pathology. These veterinary innovations not only provide new hope for pets and their owners, but may also have far-reaching implications for human oncology. Too often, pet owners facing a cancer diagnosis are left with limited treatment options, either opting for expensive and aggressive chemotherapy or doing nothing at all. Seeing an opportunity to bring personalized, accessible solutions to veterinary oncology, she co-founded Torigen to bridge this gap. The basis of Torigen's approach is its innovative cancer vaccine, which is developed using a pet's own tumor cells. Instead of relying on chemotherapy or radiation, this therapy stimulates the animal's immune system to recognize and attack cancer cells naturally. Ashley explained how this personalized immunotherapy method provides a more targeted and less invasive alternative to traditional treatments, improving both quality of life and survival rates for pets diagnosed with cancer. A significant aspect of Torigen's mission is making cancer treatment more accessible and affordable for pet owners. Traditional veterinary oncology treatments can be prohibitively expensive, with limited availability due to a small number of veterinary oncologists. By leveraging personalized vaccines, Torigen offers a treatment option that is not only more cost-effective, but also easier for general veterinarians to administer, reducing barriers to care. Additionally, many pet owners are hesitant to put their animals through chemotherapy due to concerns about side effects and quality of life. Torigen's immunotherapy approach offers an alternative that works with the pet's immune system rather than suppressing it, potentially reducing side effects. Torigen's approach has shown particularly promising results in aggressive cancer types such as hemangiosarcoma, an often fatal cancer in dogs. By using this personalized vaccine in combination with surgery, survival rates have significantly improved, offering new hope for pet owners facing difficult diagnoses. One of the most exciting advancements in veterinary medicine is the integration of digital pathology into cancer diagnostics and treatment planning. Ashley discussed how digital pathology is transforming the way Torigen processes cancer samples. By digitizing pathology slides, veterinarians and pathologists can collaborate more efficiently, ensuring faster and more accurate diagnoses. With digital pathology, expert veterinary pathologists from anywhere in the world can assess and interpret samples, overcoming geographical limitations that have historically slowed down veterinary diagnostics. This technology not only improves diagnostic precision, but also facilitates research by allowing for the collection of large-scale data sets that can be used to refine and enhance cancer treatment strategies. While Torigen's work is groundbreaking, Ashley acknowledges that veterinary oncology faces unique challenges when it comes to research and data collection. Unlike human medicine, where standardized treatment protocols and extensive clinical trials guide practice, veterinary oncology often relies on case-by-case decision-making by pet owners. Some owners opt for aggressive treatment, while others decline intervention, making it difficult to gather large-scale, standardized data. To address this, Torigen is actively conducting research and clinical studies to evaluate the effectiveness of its immunotherapy approach. The company is also expanding its focus beyond dogs and cats to include research into other animals, paving the way for more comprehensive treatment options across species. One of the most compelling aspects of Torigen's work is its potential implications for human medicine. The idea of addressing affordability up front is one of these aspects. Human cancer treatments are expensive, which can limit access to this care. If treatments can be developed based on the Torigen model, addressing affordability first, they could allow the possibility of treatment for more patients. The principles behind personalized cancer vaccines for pets align closely with emerging trends in human oncology, where immunotherapy is becoming an increasingly important treatment modality. By studying how pets respond to these vaccines, researchers can gain insights that may inform the development of similar therapies for human cancer patients. Ashley envisions a world where personalized immunotherapy is a standard part of cancer care, reducing reliance on toxic chemotherapies and providing patients, both human and animal, with more effective, less invasive treatment options. As always, I'll have links in the show notes to everything that we talked about today. Don't forget you can follow this show at People of Path on both Instagram and Twitter, or just connect with me on LinkedIn. Thank you for continuing to share the show with others. Together, let's inspire the next generation of pathologists and laboratory professionals. This show is a member of Health Podcast Network. Thanks for listening. I'm Dennis Strank, and I'll talk to you next time on the People of Pathology podcast.